Hello and welcome to episode 8 of the Wi-Fi for Beginners podcast. My name is Nigel Bowden. I'd like to welcome you to this episode. This is number 8 in a series of podcasts where we're discussing the fundamentals of wireless LAN networking. In each episode we'll take a look at different aspects of Wi-Fi networks to help build your understanding and knowledge of wireless LAN networks. With each episode I'll provide a set of slides which describe the topics covered in each episode. Although you don't need to look at the slides while you're actually listening to the audio presentation, they can be useful to go back and have a look at later on to review some of the topics in a little bit more detail, but feel free to follow along with the slides if you've got them in front of you. If you want to get hold of the slides or any of the other recordings and supporting material, you can go along to my website, which is wififorbeginners.com, where you can get hold of all supporting material for the podcast. Okay, so just a reminder that we're actually in episode 8 of the series. This series of podcasts actually breaks down into a number of modules, and in each module we look at a different major area of wireless LANs. We're actually in module number 3 now, where we're looking at wireless access points. This is the second episode within module 3, so if you missed the last episode of the podcast, which was episode number 7, which is the first one of the access point module, then you might want to skip back to that and listen to that prior to listening to this particular episode of the podcast. So just before we dive into today's material, I'm just going to do a very quick run through of what we covered in the previous episode, just to refresh your memory before we get started. So we started off by having a look at the reference model that we've been using throughout this podcast series. We recapped the fact that we can consider a traditional core distribution edge wired network, and we use wireless access points and a wireless LAN to extend the edge of our network using access points connected to edge switches, and that gives us effectively an RF extension of the edge of our network. We also then took a little bit of a look at wireless access points, what they actually physically look like, and there's a few images of typical enterprise grade access points within the slide deck that you might want to go back and have a look at. We talked about the primary job of a wireless access point, which is to convert between radio frequency signals which are carrying data to and from our clients, and that data is converted into a data flow on the Ethernet port to get the data onto our wired network. We also said that effectively a wireless access point acts as a bridge between the RF side of things and the Ethernet wired network. It converts between 802.11 and 802.3 frames. We also talked about the concept of the access point being conceptually divided into two halves. We've got the wireless side, which is our radio and antennas which talk to our wireless clients, and then the other half of the AP is the wired side of things, which is our Ethernet port, which connects us back onto our wired infrastructure. We also mentioned that many enterprise grade access points have more than one radio. They would generally have one radio dedicated to the 2.4 GHz band and one dedicated to the 5 GHz band. Each access point will also have a number of antennas. These may be internal antennas, which are inside of the chassis of the access point itself under the cover, or we may have external antennas which are physically attached to the outside of the access point, or may be connected by coaxial cables to a nearby antenna assembly. We also did a very quick recap about the concept of modulation. Modulation is where we actually vary some component of an RF signal in response to an incoming binary data stream so that we can convey binary data over an RF link. We also started to look at a number of major components that you'll find within every access point. We looked at the antennas, which are used to receive and transmit signals to and from clients, and we talked about the fact that we may have multiple antennas per radio on the access point. It's not unusual these days to have 2, 3 or even 4 antennas to allow us to use modern techniques such as beamforming and multiple streams to allow the support of higher data rates on wireless access points. We also took a very brief look on considerations for selecting internal or external antennas on an access point, and it all came down pretty much to performance and design requirements, but there is a little bit of an element of aesthetics considerations as well that may not necessarily be welcome in particular environments where external antennas maybe not perceived as looking that great. We also started to consider the radiation patterns of different types of antenna. We talked about omnidirectional antennas, which means that the antenna broadcasts its RF signal in all directions simultaneously. This is akin to a light bulb that's hanging from the ceiling. You switch it on and its light goes in all directions at once. And we discussed also the analogy of dropping a pebble into a pond, and you see the ripples of water that radiate from the point that the pebble's been dropped into the pond, and you can think of RF signals emanating from an omnidirectional antenna in a similar sort of way. And in addition to omnidirectional antennas, we have directional antennas which tend to focus their RF energy in one particular direction. A good analogy here is to think of a torch where we've got a light bulb and we put the parabolic reflector behind it, and it focuses the light energy in one particular direction. And by altering the physical characteristics of an antenna, we can get a similar effect and focus the RF energy in one particular direction where wireless LAN coverage is required. Okay, so we've finished our recap of the subjects covered in the last episode, and we're going to continue our discussion about the major components of a wireless access point. Now we're actually moving on to the AP radios, and an AP radio is responsible for taking signals from wireless clients. They're actually received by the antenna initially, and then they're passed to the radio receiver circuitry of the wireless access point. And conversely, when an access point has got some data to send out to a client, the radio circuitry is responsible for generating the RF signal, which is then passed on from the radio transmitter of the access point to the antenna to be transmitted out to the client. One point to note is that each AP radio can only transmit or receive signals at any point in time. They can only be sending signals to a wireless client or receiving signals from a particular wireless client. It can't actually transmit and receive at the same time. Being able to transmit and receive at the same time is a technique known as full duplex. Wireless access point radios are not full duplex. They transmit in one direction or the other at any point in time. This is actually known as half duplex. So just to recap, half duplex radios are used in wireless access point. This means that they can only ever be transmitting to a client or receiving data from a client. They can never be talking and listening at the same time. And this is a major difference between Wi-Fi networks and Ethernet networks that many people who are new to Wi-Fi are maybe not aware of. With an Ethernet environment, we're very used to having a full duplex connection, i.e. the Ethernet port is simultaneously transmitting data and receiving data at the same time. So on an Ethernet switch port, there'll be data traveling simultaneously in both directions between the switch port itself and the station which is attached to it. With a wireless client which is associated with a wireless access point, the data is only ever half duplex. There is only ever data going from the client to the wireless access point, or conversely from the wireless access point back to the wireless client, never in both directions at the same time. Hopefully it's fairly self-evident that a full duplex link is going to perform at least twice the speed of a half duplex link, because we can transmit and receive at the same time on a full duplex link. It's obviously going to be able to use twice as much bandwidth as a half duplex link, which can only either transmit or receive at any point in time. And this is a major difference that you need to bear in mind when considering Wi-Fi and Ethernet networks. When you're comparing them side by side, an Ethernet network which is maybe has a link that's running at 1 gig could potentially run at least twice as fast as a wireless LAN RF link, which is running at the same speed. We mentioned earlier that many enterprise grade wireless access points will have two radios, one for the 2.4 GHz band and one for the 5 GHz band, and it's worth bearing in mind that these are two separate components. They operate independently of each other, so it's not the case that we can only transmit and receive signals on the 2.4 GHz radio or transmit and receive signals on the 5 GHz radio. We can transmit and receive on both of them at the same time, and we may well have some wireless clients which maybe only support 2.4 GHz, and they'll be talking to the 2.4 GHz radio, and we may have others which will be able to support 2.4 or 5 GHz, and they maybe tend or prefer to use the 5 GHz radio. So we can be servicing clients on both the 2.4 and the 5 GHz radio at the same time. Although we're taking a very high-level view of the functions of a wireless access point, we're focusing mainly on the RF side of things and the whole conversion process across to a wired network. It's worth bearing in mind that wireless access point actually provides a whole host of other functions, and obviously we're going to have many additional components to support those functions. There's obviously going to be CPUs, memory, custom chipsets such as ASIC and digital signal processing devices that are providing a whole slew of different features. An access point will typically provide functions such as traffic filtering, maybe rate limiting of traffic. It's going to be processing IP frames to and from the management port of the AP itself. It's going to provide VLAN support to enable us to logically separate traffic. There's a whole host of features which will be provided by all of these additional components. We're not going to dive into the detail of these particular components because we don't get much visibility of them, but it's worth bearing in mind that they're there, and that the performance that you get out of an access point is related to the quality and types of components which have been installed into the access point. We've mentioned a number of times that the function of the AP is to get wireless packets onto our wired network, and so obviously we need some type of Ethernet connection for the access point into the wired network. So every access point will always have at least one Ethernet port. More and more these days we're seeing maybe two Ethernet ports in some instances as we're hitting higher speeds for our wireless clients, and we may in some cases potentially exceed the 1 gigabit limit of a single Ethernet. Also, we're going to be seeing access points connected by mgig Ethernet ports. So these are Ethernet ports which go in excess of 1 gigabit per second. They typically can go at 2.5 or 5 gigabits per second, and they're going to be emerging in the very near future as we're getting faster and faster data rates over the air for wireless LAN clients. Then there's the potential that we could overrun a 1 gig port and need these higher throughput rates. It's very common practice to power wireless access points from the switch port that they're connected to. This is known as PoE, Power over Ethernet, which you're probably fairly familiar with already. It's often used for powering things like phones and other devices which are connected to switches. So we can power our wireless access point from a PoE switch port, but it's worth remembering that there are actually two main PoE standards. We've got 802.3AF, which can supply up to 15.4 watts of power to our access point, and there's also the 802.3AT PoE standard, which provides up to 25.2 watts. The AT standard is also often known as PoE Plus if you're dealing with vendors such as Cisco. And the reason that it's worth bearing in mind these two different standards is that on more recent access points where we've started to support the 802.11ac standard, the 11ac standard actually requires higher power to its components. We're supporting more spatial streams and wider channel widths, things like this. They all need additional power, and we find that the original 802.3AF PoE standard isn't enough to power the newer 11ac access points, and the power requirements are only going to increase over time as the standards evolve and faster speeds are made available. So it's well worth checking if you're deploying a wireless network that your PoE switches do actually support 802.3AT, the PoE Plus standard, rather than the older 802.3AF standard. And finally, in our discussion of access point components, just want to touch very briefly on the console port that's usually found on the majority of enterprise grade wireless access points. Usually find it on the rear. If you flip over the access point on the back as well as your Ethernet port, very often you'll find a console port very close by. The console port itself may occasionally be used for an initial configuration setup of the wireless access point. Many access points these days, you tend to plug them in, they'll get a DHCP address from the network and they'll find their way back to either a wireless controller or maybe a cloud service. But in some models you can actually use the console port to potentially give the device an initial IP address, default gateway, that type of thing, just to get it onto the network and to get it working. You don't generally use it for the full-blown configuration of the device to configure up all the various parameters such as SSIDs, VLANs, all the fine-grained detail. That's generally done from a management system or a wireless LAN controller or some sort of cloud-based controller system. So it's very much used for an initial configuration, if at all, in terms of configuration on the access point. The area it's most likely to be used is diagnosis of issues. It's very useful for debugging issues or for APs that maybe can't find their controller or they're having some sort of connectivity issue. It can be used to observe the log messages that are being produced by the access point when it's having difficulties. Some organisations also like to cable up the console port to provide an out-of-band management connection to each of the access points, but this tends to be quite an expensive proposition if you've got many hundreds of APs and you've got to cable all of the console ports back to terminal servers somewhere in a data centre or a wiring closet. So it's generally used on an ad hoc basis as required for assistance with diagnosis of issues. The console port itself tends to be a fairly standard serial port, very similar to the types that you'll find on a switch or a router, and tends to use a similar sort of cable that is used to get into the console port of switches and routers. The access speeds for console ports vary between manufacturers. It can be anywhere between 9600 bits per second right up to 115k. You need to check with your manufacturer to see what's appropriate for their particular device. Okay, it's almost time to wrap things up. I know I said that wireless access point console ports were going to be the last thing we were going to discuss, but I think we've got time just to move on and squeeze in one more topic. Very important topic actually. We're going to talk about the installation of wireless access points and some of the considerations that we need to take into account when we're going to be installing APs throughout a facility. So our overall aim when we're installing wireless access points is generally to provide a continuous layer of coverage throughout the area that we need our wireless LAN to provide service to our clients, and we can think of each wireless access point as providing a pool of coverage, very much going back to our light bulb analogy. You can imagine as we mount access points on walls and in ceilings throughout a facility, they're going to provide pools of coverage like pools of light throughout the facility, and we tend to call these pools of coverage cells. If you're familiar with cellular phone technology, you've probably heard a similar sort of terminology there. So each access point provides a cell of coverage, and within that area any clients passing through that area will be able to talk with the access point and have connectivity back to our wired network. And as clients move throughout a facility, they'll tend to roam from access point to access point, hopefully picking up the closest access point which is going to give them the best signal and the best connectivity back to the network. So as they move from cell to cell, they'll hopefully roam and associate with each access point along the way so that they get continuous wireless coverage throughout the facility. When we come to actually mount our wireless access points, we generally want to mount them fairly high up. Generally something like ceiling height is what we're aiming for. And again, thinking about the light bulb analogy, you can think about the way that light travels, and RF signals are going to travel in a very similar manner. When you're moving around a facility, just bear in mind, if you can see an AP, then there's a very good chance that the AP can see you from an RF perspective. In many office type environments, APs tend to be mounted on the ceiling. Very often this will be suspended directly onto the ceiling grid, and many access points are supplied with mounting kits to specifically allow mounting onto ceiling grids. But if ceiling grids aren't available, occasionally we have to mount onto solid ceilings or as an alternative perhaps walls using some sort of mounting bracket. But walls and ceilings aren't the only places we might mount an access point. Sometimes we can mount them onto poles, especially if we've got some sort of external wireless coverage that we need to provide. Occasionally they'll be mounted on external walls as well to provide coverage in areas such as car parks or walkways between buildings, and you can expect to find them in a whole host of unusual places where there have been opportunities to mount them to provide the required wireless coverage. Just a few rules of thumb when installing wireless access points. Generally we want to try and keep them up high, to try and keep them in line of sight of clients. If you've got line of sight between a client and an access point, you're generally going to get pretty good RF signal. We want to avoid putting them near to metal objects. We've talked a little bit about reflection of RF signals, so keeping the access points away from metal objects helps to avoid some of the issues we get from the reflection of RF signals. We certainly want to avoid putting them behind any sort of obstruction, because this is at best going to just reduce the available signal level, and at worst we're going to get all sorts of other types of reflection and absorption effects. We certainly want to avoid putting them near to any other known sources of interference. So if you've got things like microwave ovens or decked phone systems or security cameras that use the Wi-Fi bands, we certainly want to keep our access points well away from those. We also certainly want to avoid putting them into closets, into any sort of ceiling void or any sort of box enclosure, unless it's a specific enclosure that's been designed to be used with access points. Another consideration when installing access points is we need to remember that we've got to get cable to the access points to provide our data connectivity back to our edge switch, and we certainly need to think about things such as the 100 meter cable limit, which we hit with things like Cat5e, Cat6, and we need to make sure that we're well within a 100 meter run from our wireless access point to the nearest switch that we're going to be connecting up to. And when calculating the distance between an access point and the switch, don't forget to factor in things like the vertical distances involved and also the length of patch leads at each end of the connection. We've previously spoken about powering access points using PoE Ethernet switch ports, which can provide power over the Ethernet cable to power the AP directly. Occasionally this may not be viable if a suitable PoE port's not available, so sometimes an alternative can be to provide a local mains socket next to the AP to power the AP off a mains supply, but this tends to be a very expensive option due to the cost of running the mains cable to the vicinity of the access point. Another alternative is to actually use power injectors at the switch end of the connection, which can be used to mimic the action of a PoE switch port by injecting power onto a couple of the Ethernet cable wires. Okay, well I think that probably does wrap things up for this particular episode of the podcast. We've still got a few more areas to look at in our discussion of wireless access points, and we'll have a look at those in the next episode. So just very briefly, just to recap what we've covered in this particular episode, we continued our discussion of wireless access point components. We looked at the radios that we find in a wireless access point, and we talked about the fact that they can either transmit or receive, but they can't do both at the same time. They actually provide what's called a half duplex mode of operation, so that they can only talk or listen but never do both at the same time, and we contrasted this with the full duplex capabilities of Ethernet. We also talked about the fact that most APs tend to have at least two radios in them dedicated to the 2.4 and the 5 GHz band, and the two radios actually operate independently of each other, and they can both be handling traffic independently, talking to different clients at the same time, but they are both still subject to the restrictions of half duplex operation. We also talked briefly about the Ethernet port within an access point and the fact that it gives us a connection to the edge of our wired network. Ethernet ports tend to be 1 gigabit per second, but we are seeing support now for higher speed Ethernet as the speeds available from Wi-Fi standards are increasing above the 1 gigabit threshold. The Ethernet port may be used to provide power to the access point as well, so the use of PoE, and we mentioned the 802.3AF standard, 802.3AT, and the requirement for support for the .3AT standard PoE+, where possible when using modern wireless access points. We also briefly mentioned the console port, which is generally used for diagnostics and initial setup of an access point. And then finally we had a very brief look at wireless access point installation considerations, where we talked about the pools of coverage that we need to provide and the fact that we generally want to try and mount the APs fairly high up so that we've got good line of sight between our APs and our clients. We generally want to avoid putting them near metal objects, behind any sort of obstructions, or near any sources of known interference. We also need to remember cabling considerations, and we need to keep within our 100 meter limit between our access point and our switch port. And finally, we need to remember that we've got to power our access point either through PoE, through a local main supply, or perhaps power injectors if we don't have PoE switch ports. Well, thanks for joining me on this particular episode of the podcast. I hope you found it of use. Don't forget that you can get along to the website, which is wififorbeginners.com, where you can find all of the audio presentations, all of the slides, quizzes and references to other sources of useful information that will help you with your study of wireless LAN networking. I look forward to joining you again soon on the next episode of the Wi-Fi for Beginners podcast.